Hello, welcome. Today we are here to discuss about one of the potential problem in data structures, which is to check whether the given string is a palindrome or not. So basically palindromes are the strings that read same forwards and backwards. So words like madam, race car, known, etc. are the great examples. So this is very basic level question, but this will help us to understand one of the important problem solving technique called two-pointer technique. So this is one of the important technique across the data structures, which will help us to solve many number of questions. So this we'll see later half of the video. So coming back to the question, given a string, we need to check whether it is a palindrome or not. So before we start solving the question, let me tell you the process that we follow to solve every question. So basically, the first step that we do is to understand the question. So when I say understanding the question, we will read the question, we will understand the inputs, we will identify the outputs and also the time constraints. This will be the first step. And next step is to identify the brute force solution. Next step is to identify the brute force solution. So when I say brute force solution, this is the easiest and straightforward way to solve the question. Like pretty straightforward way. And next thing is optimized solution. So at the end of the day, for every given question, we need to find out the optimized solution. So, so there are basically two ways to find out the optimized solution. First way is to So most of the times we will get the solution, optimize the solution from the brute force solution itself. So basically we identify parts of the code where it is taking time or using extra space and we'll try to reduce it. This is the first way. And second way is using completely a new approach. So these are the two ways. I know it is a little bit confusing, but yeah, don't worry about it. We will see in further videos about these things clearly. So coming back to us, we will start with the brute force approach. And yes, we know the first step is to understand the question. So for the question, we need to check whether it is a palindrome or not. So how we can say whether, so let's take an example. So given input string is MADAM, madam. So we need to check, we need to say whether it is a palindrome or not. So how we can say this is a palindrome? So if we identify or if we understand the definition of palindrome clearly, the string or the word will be same from forwards and also backwards, right? So now if we read it from the beginning, it will be MADAM, which is madam. Now if we read it from the end, okay, it will be same MADAM, which is madam again. So now we can say, okay, this string is a palindromic string. Now let's take one more example. Now let's say car. Okay. Now if we read this particular string from forwards, it will be CAR, car. Now if we read it from the backwards, it will be RAC, which will be rack, which is not same as the original string, the given string. So car and rack doesn't match, and hence this is not a palindromic string. Okay. Now let's start. I hope the question is pretty clear to everyone. Now let's go to the second step, which is to understand or to identify or to find the brute force solution. So in this question, brute force is pretty straightforward. Like it is basically, it comes from the definition of the palindrome itself. So what is the definition of the palindrome? It reads same from forwards and backwards. Now, when I say forwards, it will be the given string itself. But when I say backwards, it will be reverse of the string. So the brute force approach is something like this. So the first thing is we need to find the reverse of the given string. And the second step is after finding out the given reverse, we need to compare the given string with the reversed string. So these are the pretty straightforward brute force solution. So from forwards, we know what is input string. From backwards means we need to find the reverse of the given string. And after reversing the given string, we just need to compare both the strings. Compare both the strings, and if they are matching, we will say, okay, this particular string is a palindrome. If they are not matching, we will say they are not palindromic strings. That's all. So this is what the brute force approach is. So now let's take an example and try to do with the brute force approach. So let me take an example. So example is, so input string, let's take it as M itself, and the reverse of the input string will be how it will be, guys. The reversed string will be equals to MADM2. So now if we start comparing the string, yes. So now if we start comparing the string, what is the character that we have at first at 0th index? Basically, we have M at both the strings. So they are matching. We will move one step. We'll compare A and A. We'll move one step. We'll compare D and D. We'll move one step. We will compare A and A. We'll move one step. We'll compare M and M. We'll move one step. And we are at end of both the strings. Now, both the strings are matching. Hence, we will say they are palindromic strings. So this is what the brute force approach is. Now let's take one more example where this particular brute force approach fails. So example number 2, where input string will be, let's take car. And what will be the reverse, guys? Reverse equals to RAC. Okay. Now, what we will do is, yes. Now let's compare the given original string and also the reverse string. So what is the first character that we have in input string? It is C. What is the first character in the reverse string? It is R. So now let's compare these two. Are they matching? No, they are not matching. Hence, this is not a palindromic string. So they are not palindromes. The given string is not a palindrome. That's all. Very simple. So this is what the brute force solution is. Now, yeah, this solution works pretty fine and the steps are also pretty simple. We'll just reverse the string and we'll compare the given string. So what is taking time or here around this in this particular approach? So if we observe carefully, whenever we are reversing the string, we are storing the reversed string in one more new variable. So here it is reverse string, here it is RS. So whenever we are reversing the given string, okay, we are storing it in a new variable, which is taking extra space. Okay, now you can ask me, so it is just 5 characters or 4 characters or 3 characters. What happens if we take that 5 characters as space? So when it comes to real world, guys, so we will have a strings which will have a huge number of characters. It can be go beyond 1 lakh characters too. So in that case, reversing the string and storing 1 lakh characters is too much amount of space. So this is first thing which will take additional space. Okay. And second thing is basically, so if you observe internally, we will use some reverse method or something to reverse this string. Even that will take n time, right? Like it will take some time. And after reversing, we will compare the two strings and even that will take some time. So time is one more constraint which we can try to reduce it. Okay. So the problem with this particular approach is space complexity. Mainly it is space. Forget about the time, but mainly it is space. Additional space which is required to store the reversed string. This is the potential problem with this approach. Now, let's try to figure out the optimized solution. So if you want to figure out the optimized solution, as I said, there are 2 ways. One is to identify from the brute force solution, and second way is to use completely a new approach. As I said in the beginning of our video, we will be using a 2-pointer approach. Now, we will use the same 2-pointer approach to solve this particular question. Okay. So now, okay, before that, can I, okay, I guess we don't need a code for this brute force approach. I'm just skipping this particular part. So let me directly jump into 2-pointer technique. So 2-pointer technique, which is pretty simple technique and very powerful. This will this will help us to solve many number of questions. We will see. I'll give you a list of questions too in the end. So this is the two-pointer technique. So let me tell you what this two-pointer technique actually is. So basically, two-pointer technique, we will use, as the name mentions, we will use 2 pointers. One will be at the beginning of the string, one will be at the end of the string. So now let me take an example and clearly explain how this actually works. So string equals to M A D A M. Okay, so this is the given string. Now I'll take 2 pointers. One pointer will be at the beginning and the other pointer will be at the end. Okay, so this pointer we will name it as P1. Okay, and this we will name it as pointer 2. So we have 2 pointers where first pointer is pointing to the first index of the given string and pointer 2 is pointing to the last index. Now we will compare these two indexes, these two P1 and P2 pointers, characters. So now if you see what is the character at P1 position, it is M. What is the character at P2 position? It is also M. Now if we compare these two, they are same, right? M and M are same. Now what we will do is we will simply move our pointer P1 one step forward and pointer P2 one step backwards, inwards. Basically, the pointers. So in this particular two-pointer approach, both pointers will be always moving in inwards direction. So they'll always move in inwards direction. Okay. Let me write it down. Yes. Inwards direction. So both pointers will always move in inward direction. Now our pointers P1 is pointing to first index and pointer P2 is pointing to third index. Now we'll compare these two strings again. A at P1, A at P2. Again, obviously they are matching. So we will move our P1 one step forward. P2 will also move one step forward. Now what is the character at P1? It is D. What is the character at P2? It is also D. They are matching. Now we will move one step forward and pointer P1 will be pointing to index 3, pointer P2 will be pointing to index 1. Okay, so in this particular approach, the first step, as I said, always pointers will move in inwards direction. And second important thing is once the pointers cross each other. Okay, so once if the pointers cross each other, we will stop the process. So once the pointer cross each other, we will simply stop the process, which means like whenever we are using this two-pointer technique, that okay, there are a few things that you need to clearly understand. First thing is pointers will move inwards, and second thing is once the pointers cross each other, we need to stop the process. This is how the two-pointer technique works. And coming to our question, if we check half of the string, okay, as we know, okay, as we know, this is the given string, which is madam. If you reverse the given string, it will be stored in another string. So let me take you to the example again clearly, guys. So let me take an example which is not a palindrome. Okay. So example string is, let's take CROSS cross. Now, you guys say me, is it a palindrome? No, right? Because if we see it from the first, it is cross. If we see it from the back, it is SORC, right? SSORC, which is not same. So now how the brute force works, basically we'll simply reverse the given string. So what will be the reverse string? SSORC. After this, what we will do, we will compare the first index of given original string with first index of reversed string. If you clearly observe here, what is the first index? S, which is last index of the original string. Okay, if you clearly observe here, the first index of the reversed string is the last index of the original string. Is this clear, guys? So we are comparing our first index with last index, and once we are done half, we know that we already compared first half with second half, which means the entire string is already compared. So we will stop the process. In the same way, here also, this is how our second condition satisfies. Once pointers cross each other, we will simply stop the process. So how we are satisfying this condition is from this particular point. Is this clear to everyone, guys? So this is what your two-pointer technique is. So let's jump into the next thing. Just give me a moment. Just delete this part. Now let's do, okay, whatever the two-pointer technique was there, let's convert it into code. Okay, so I'll not write complete code. Instead, we'll write a pseudo code. Okay, so the first thing is we have two pointers. Int p1 equals to 0, which means beginning of the string, and p2 will be equals to at the end, right? At the end, which means string, given string. Let's say s1 is the given string, s1 dot length minus 1. S1 dot length minus 1. So pointer 1 is at initial position, pointer 2 is at the end of the string. After that, what we will do, we need to compare the characters at the given pointers. So what is the string name? S1 dot char at. So in Java, so I'm writing code in Java. In Java, we have a method called char at, which will get the character at the given index. Okay, while S1, okay, which will give us the character at the given string. So now what is our condition? How many times we need to repeat the process? While P1 is less than or equal to P2, which means P1 and P2 have not crossed it yet. Okay. Now, what is the character at P1? How to get the character at P1? S1 dot char at P1. If they are matching, S1 dot char at P2. Let's say, suppose if they are matching, what we will do? We'll simply move one step forward, right? So P1 will be plus plus, P2 will be minus minus. So why we are doing P1 plus plus and P2 minus minus is P1 is at the extreme left end and P2 is at the extreme right end. Okay, so we will simply move P1 inside. Okay, and P2 will be going left side. That's why P1 will be plus plus, P2 will be minus minus. And nextly, after this, let's say if they are not matching, else if s1 dot char at p1 not equals to s2 dot char at p2. Okay, now let's say if these characters are not matching, then what we need to do, we will simply stop the process. We will simply say not palindromes. That's all. Okay, we will break the loop. We will simply say not palindromes and we will break the loop. That's all, guys. So this is the very simpler pseudocode, very basic pseudocode I was given to you. I hope this is clear. So let me just go take you through this particular code. So P1 will be pointing to the initial beginning of the string, P2 will be pointing to the ending of the string. We are checking this condition because as we know, the second condition is pointers cross each other, we will stop the process. So if the pointers cross each other, which means P1 and P2 will be always, they should not cross. If they are crossing, we will stop. So when P1 and P2 will cross, P1 and P2 will cross if P1 is greater than P2, right? So if P1 is greater than P2, we will stop the process. So that is the condition here. And what is our process? Every time we'll compare the characters at P1 with P2. If they are matching, fine, just increase the pointers and move forward. If they are not matching, we will simply say they are not palindromes, because even one character is mismatched, then we can say that they are not palindromes. Okay, is this, I hope this particular thing is clear to everyone. So let me just jump into the next thing. So what are the things that we have? Okay, we have checked. Okay, so this is what the two-pointer technique is. This will help you to solve a lot of questions. I hope this is clear. Thank you.